Hello, my project is about BERT sentiment analysis to detect Twitter sarcasm. The project topic falls under the text classification competition in the final project of CS410. There are two main goals of this project. First, to explore sentiment analysis using a state-of-the-art method such as BERT. Second, to beat the baseline score using the given training and sample datasets. I am the only member of this project. In this project, I'm proposing a naive approach to train and evaluate the model. I hypothesize the context does not always support the sentiment of a response. I hypothesize there are two types of context. First is positive context, a context that supports the sentiment of a response. Second is negative context, a context that not support the sentiment of a response. In this project, I consider only the response to train and evaluate the model, completely ignoring the context. I use two models in my experiments. First is the BERT large uncased model. Second is the BERT base uncased model. I use the hyperparameters as shown here. They are suggested in the original BERT paper. For the demo, I use Google Colab environment. To train and evaluate the models, I use the paid Pro version. The main step of the demo as follows. Load the saved train model to Colab session. The model file is stored in the project Google Drive folder. Run the evaluation using the model and the testing dataset. Save the evaluation result to file. And finally, post the result file to the live data lab for scoring. To start the demo, we open the Colab notebook. The link is available in the project GitHub repository. To produce the evaluation result, we need to execute the Colab notebook from the first step until the end in sequence. First step is to configure the Colab environment. I'm using Hugging Face library. We need to install the module first by clicking the play button and waiting for it to complete. Next, we need to import all the required Python modules for the notebook. Next, we will copy the already trained module from project Google Drive folder to the Colab sessions. For this, we need to log in using Google account. It will prompt a verification code. Copy-paste the code to the verification code textbook and press enter. Next, we review the testing dataset, print the maximum response character length and sample response text to preview the data. Next, we encode the input testing data using the tokenizer and prepare the data loader. Data loader is used to pass the data in batches to the model for evaluation. Next is the actual evaluation process. We set the model to evaluation mode and start the evaluation. The progress bar will show us the evaluation progress. Once the evaluation is done, the code will prompt an evaluation is done message. Next is to generate the evaluation result, answer.txt. We will use this file to post the result to Live Data Lab for scoring. Here we have our answer.txt file using the already trained model stored in Project Google Drive. Now let's post the file to Live Data Lab and get the scores. The result shows, as expected, BERT large model will outperform BERT base model. Surprisingly, the base model has a better recall score than the large model. In this case, if the system environment used to train and evaluate the model is restricted in terms of computing power and memory size, BERT-based model is a great option to use. If computing power and memory size is not an issue, BERT's large model is a better option to use rather than the base model in most of the NLP tasks. This is the end of the demo. Thank you.